so sample exam 1, and do 5. Okay, 32 you said? Okay, at 32 it tells us here that we have an interval a to b. Function is positive, increasing, and concave up. So general shape might be something like that, possibly. That would be positive, increasing, and concave up. True. And the question says let A be the integral, the area under the curve, the true area. L is the left Riemann sum, R is the right Riemann sum, and T is the trapezoidal approximation. And ultimately, we want to know which of these is true. In other words, which one gives us the biggest value, which one gives the smallest value. Basically, order the values in terms of biggest to smallest. Well, ultimately, think about if I did the left Riemann sum here on A to B. Okay, my rectangles would be all what? Under or over? Under. Would be all under. Okay, and so comparing L and R, we know that for a fact that would be true. True. We also know that if we drew RM rectangles, those would all be what? Over. So ultimately, wouldn't I also know then that were true as well? A being the actual area. And I think they just used A, L, R, and T, right? So the question is, where does this trapezoid fit in? Well, keeping in mind if this is concave up and I were to draw points on here and connect those points, okay, what kind of situation would I have then? It's concave up, it'd be over, wouldn't it? Now, would it be over as much as R is over? No. So ultimately, then, what's our answer then? Should be this one, shouldn't it? And so therefore, we'd give letter B, looks like? Nope. A. Hope that's what I said, right? Good. Questions on that one? What else? Up to 33. Scott? 31, we have an f function here, which is 1 over t greater than 0, domain. And the question here says, for what value of t is f prime of t equal to the average rate of change of f on the closed interval a to b? So ultimately, that's a mean value theorem problem. It's asking us for the average rate of change is the slope. So when is the derivative equal to the slope between the endpoints? So the derivative here, of course, is negative 1 over t squared. Again, another common function that you should have memorized at this point, and if you don't, you can use the power rule or the quotient rule and figure it out. But like I said, I would start having some of these common functions memorized so that you don't have to waste time doing all that. So here's our derivative. And our slope between endpoints here, if I did f of a, I'd get 1 over a. And if I did f of b, I'd get 1 over b. And so my slope then would be 1 over b minus 1 over a, all over b minus a. So if I calculate my slope, I'd get that. Now, in terms of simplifying this, which we certainly don't want to leave our stuff like this, the common denominator of what's making this complex is AB. So if we multiply the top by AB and the bottom by AB, we'd ultimately get AB times 1 over B would be A. AB times 1 over A would be B. And then the bottom we'd have AB. And then B minus A. I didn't multiply that out on purpose because ultimately what do we got going on here with these two? They're the same quantity, just one would be positive, one would be negative, wouldn't they? So ultimately if I simplify those, wouldn't I have negative 1 over AB here? And with that, I want to know when does the derivative equal that. So from here I'd use the cross product property to get negative AB equals negative t squared, which ultimately would give me AB equals t squared. And if I take the square root, I'd get plus and minus radical AB. That's my t. Now, why is the negative no good? What did it tell us about time? It said t greater than 0, didn't it? So ultimately, since that's the case, we just get t equals radical AB. Should correspond to letter B. Looks like. What else? 33, Mike. 29. 29 we have to save for another time because that's in chapter 7. So you can put a star by 29, we'll revisit that another time. Right? 30 we have a function that has f is tangent x. And it says this g function is x squared, it says. So we got f is tangent x, g is x squared. And the question is, at what value of x in the interval 0 to pi do the graphs of f and g have parallel tangent lines? Well, keep in mind, what would that indicate if they had parallel tangent lines in the language of calculus? Yeah, they'd have to have the same slope, wouldn't it? So in other words, again, in terms of calculus, that means their what's would have to be the same. Their derivatives would have to be equal. True? So tangent x is derivative, secant squared x, and g prime here would be 2x. And so ultimately we'd want to know on that interval, when are those two things equal? Now here's a good lesson for the day is how many seconds should I spend on algebraically solving this sentence? 0. Do not spend 1 second on doing the algebra here. Okay? This is a calculator problem. Okay? Recognize it as such and put it in your calculator. So if we put in our y equals, we got on the left side we can 1 divided by cosine x squared. 2x. I don't know. You can call TI and see if you can lobby for that. Window wise, we go from 0 to pi was the window we're after, right? You don't really need to change the scale necessarily here, I guess, but I will just for argument's sake. And let's see what happens. I got -4 to 4 on the y window. Hopefully that'll be good, but we'll see what happens here. We know somewhat what secant squared should look like there. There's our secant squared, and looks like we got no intersection here. Close, but no cigar there, but looks like there's one here. So let's change our window, go a little higher, maybe go up to 6 and see if we see that one. I'm gonna tell you right now too, if you just did a standard window on this would look like it's an intersection point. But if you zoomed in, you'd see that it's not. But ultimately, it looks like that's our only value. So if we do our intersection command, looks like 2.083, which would be letter C. All right. Another thing too, what might have been a giveaway here that this was a calculator problem. Yeah, look at the answers. I mean, those aren't non-calculator answers, are they? Okay. Good question. What else? How about between 34 and 38? Mike?
36.
Okay, on 36 we have two functions, e to the x squared minus 2 and 4 minus x squared, and we want to know the area enclosed by these two graphs. Okay. So once again, calculator problem. We graph these two, check it out, see what we got here. We got e raised to the x squared minus 2, and then square root of 4 minus x squared. And if we just going to do a standard zoom here and see what we see, adjust our window accordingly. So there's our e to the x squared. And there's our half circle. Zoom in on that so we can see it a little bit better here. Now, as we've discussed here, if we're going to find the area enclosed by a region like this, if you look at this region, the circle function is always on the top and the e function is always on the bottom, isn't it? So therefore I could set myself up an integral then that was the 4 minus x squared function on top minus the other function, e to the x squared minus 2 on the bottom, dx. So that would be my integrand, knowing that the top is always the circle function and the bottom is always the e function. What issue do I have besides that? Yeah, the limits. So ultimately I could set these two equal to each other and try to use algebra to solve that. Okay? And you'd find that's quite impossible for techniques that we have. So, but otherwise we wouldn't waste any time even if it was a simple equation to solve because we have a calculator. So we do our intersection command here. Really doesn't matter which of these you find here because you can see that there's symmetry here. You can find both just to be safe, but recognizing the symmetry here, we'd have 1.1372792. And how many decimals should we use here on our integrand? All of them. Remember, you're using a rounded answer to calculate something new. You better use every possible one that you have here. So if we go negative 1.1372792, positive 1.1372792, get the most accurate answer here. So from there, if you do your calculation, if I do my math 9, and my integrand here is square root of 4 minus x squared minus, squared minus 2. Get 5.0495, which corresponds, looks like to letter D. As far apart as those answers are on the multiple choice, if you just rounded to 3 decimal places, could you likely get that same answer and pick out the right one? Yeah. Probably. But like I said, if you are going to use something you found in a calculator to make a new calculation, use all the decimals possible that you have. Okay, we'll go ahead and